So, good evening, everyone. Welcome to the first dissemination session under the Ensure project. First of all, I will give a brief description about introduction to the Ensure project, which is sponsored by the European Union. Ensure stands for Empowering Net Zero Skills for Sri Lankans' Sustainable and Resilient Future. This project aims to meet Sri Lanka's commitment to net zero emissions by 2050. The Ensure project focuses on bridging critical skill gaps in emerging sustainable technologies through the development of modular training programs, stackable master's degrees, and strengthening the academia industry government collaborations. The project will enhance the capacity of Sri Lanka's higher education and vocational training systems. So with this, I will briefly introduce the partners. The main partner of the project, there are 5 local partners along with one professional institute. The project is led by the Sri Lanka Institute of Information Technology, which is SLIT. Other partners are University of Runa, University of Peradeniya, Southeastern University of Sri Lanka, University of Jaffna, and the Tertiary and Vocational Education Commission of Sri Lanka, or TVEC. And Sri Lanka Energy Managers Association is also a partner, a local partner in the project. And we have 4 international partners from Italy. There is Politecnico di Torino, then University of Galway from Ireland, Vallehia University of Targoviste from Romania, Warsaw University of Technology from Poland, and Trier University of Applied Sciences, or IFAS, from Germany. So this is about the project. This is the first dissemination seminar, and it is being delivered by Mr. Navoda Senanayake. And this seminar is on understanding net zero and how to achieve it. And it will cover applying material flow analysis, circular economic strategies, and calculated impact results for industrial decarbonization. And today's speaker is Mr. Navoda Senanayake, who is the project manager in International Project Management attached to the Institute of Applied Material Flow Management at IAFS, Germany. Mr. Navoda Senanayake is also working for his doctoral degree at the same institute, at the Technical University of Birkendheim, Freiburg. He obtained his BSc Engineering in Special Mineral Processing Technologies from University of Uwe-Wellassa, and also he has obtained his Master of Science from Germany. So may I now invite Mr. Navoda Senanayake to start his talk. Over to you, Navoda.
Yes, thank you. I think you all can hear me, and also I think you can hear my, so you can see my presentation, right? Okay.
Yes, we can see it.
Okay. So thank you very much for the introduction, and good afternoon from Germany, and also I think it's around 7 o'clock in Sri Lanka. So first of all, thank you for the introduction. And yes, I'm originally from Sri Lanka, but now living in Germany. Working also for the environmental campus Birkenfeld, which is a second or like a sister university from the applied science of Trier. So before we go into our main topic, which is the net zero, understanding net zero and how to achieve it, I think it would be good to give a small introduction from why actually our institute and our university is capable of actually talking about net zero, to give a small introduction about where we're coming from and what we do actually. So our university is called as Umwelt Campus Birkenfeld, that is the German word for environmental. So we are in the international context, we are using environmental campus Birkenfeld. Birkenfeld is actually the city where we are located. And it is now we are celebrating this year 30 years of our university. It is not that much old, but we were able to make a big impact towards the environmental and sustainability criteria. So it was actually built by the US Army or USA after the World War as a military hospital. And after the German reunification, or like when the East Germany and West Germany got together, it was given to the state. So then they converted it into a university. So in 1996, so they started as a university. And now Germany's greenest university is our university, which is located in the same place, and there are no any other sub-locations. So we are operating as a separate university, and our main university is actually Applied Science University of Trier. So the university is actually built with the niche market, or I would say with a niche objective to work on the sustainability and also environmental sciences. So we are Applied Science University. And during the last few years, I'm working here since 2020 in the permanent position, but I used to be a master student here as well since 2017. And during the last few years, we were able to achieve a lot of credentials, like the German Sustainability Award, which is like the elite kind of uh, like a supreme kind of recognition coming from Germany. And also from the Green Metrics, we are ranked as number 4 globally and number 1 in Germany. And it is a very competitive metric that is done by a university in Indonesia. And also we have some other credentials in the Sustainable Development Solution Network and also Fair Trade University and these kind of awards. So what is special about us is that we are categorized, or we can name us as a zero emission campus, because as you can see, we are using 100% renewable heat supply. And if I point here, this area where you can see on my mouse, this is industrial area, and in this part where we have a biogas plant and a cogeneration plant where they collect all the waste from the campus and the nearby community, and they generate heat and electricity, and then they send back to us. And also you can see all the rooftops, not all, but 95% of the rooftops are covered by PV. So we generate our electricity more than what we require during the summer. And also we are sending them to the grid. And also we are using the electricity coming from the cogeneration plant during the winter times. And we have solar thermal, vapor absorption chillers to convert solar heat into cooling during the summer. And also we have a geothermal system. So we are inviting a lot of guests, international counterparts to our campus to show it as a model. And also there are a lot of institutes attached to the campus as well. So these are some of the not some all the institutes, but some of them are working as separately outside from the university but attached to the university. So IFAS, where I'm coming from, Institute for Angewandte Software Management, which is the German acronym, and it is translated into Institute for Applied Material Flow Management. And this is our institute is the in terms of the turnover, the largest in the state. We are operating as a non-profit research institute, and though the campus is quite small, but well equipped with several competencies as institutes. And our institute was founded in 2001, and we are celebrating 25th anniversary this year. And we are basically promoting circular economy and material flow analysis or material flow management. And actually, if someone asks, our core business is uh, circular economy. We are promoting circular economy, and we are mainly funded by third European. We are in the category covered by the government, but nevertheless, we find our own money from our own or direct business engagement, as well as third-party funds like European funds, Horizon funds, and development bank funds like that. So in terms of turnover, we are the largest institute in the Rhineland-Palatinate, which is the state where we are located. And at the moment, we have around 80 employees, excluding the research assistants and the interns who are already with us, because we recruit students as well for their internships, theses, and also to work with our projects. So as I told, we are categorized as a research institute, but we are mainly developing concepts and circular economic strategies for any kind of system. And we have worked with more than nearly 80, 60, I would say between 60 countries we are working, and we have worked more than 80, I would say. At the moment, we have relations with like 60 countries, ongoing projects. So we have a quite good track record working in the sectors for energy, waste, as well as circular economy strategic developments. So I am attached to the international department, which is a very diverse part, but I go from the out of 80 employees, we have around 10, which is quite diverse. We have Colombians, Indians, I'm the only Sri Lankan, and then we have Japanese, Moroccan, Italy, and so far. So we are quite competent in terms of projects in the international context for Asia, South America. Mainly these days, we are working a lot in South America and African region. So after the COVID, the engagement with the Sri Lanka was a little low because we had a lot of projects with Sri Lanka as well, some academic relations as well as some business related projects. So now we can come to our topic. So that is the background. So we are quite in this field, and we have worked a lot in these kind of projects during the last 25 years, and for me it's the seventh year now. And we are also dealing a lot. So I'm attached to the international department, and I am specialized, or I'm mostly interested in energy and greenhouse gas management. So first, when we have to understand about net zero, we all know that the world is now really flooded with the decarbonization, net zero, carbon neutrality, net carbon negative, carbon positive, and all kind of these things. So if you go to internet and if you just type what is decarbonization, you will get hundreds of definitions from different organizations, different platforms, and also from different books. So you will get a lot of definition. So in simple terms, the decarbonization means process of eliminating greenhouse gas emissions by moving or by shifting to low or no carbon practices. So that is the simplest way we can frame it. So, and then we are also talking about everything related to carbon, and we are all summarizing it, or like we are linking it to the CO2, and then we have to ask the question why CO2 is a big deal. So you will see when I go into details into some of the example case studies, some people or like it as a challenge that people are not aware with this. So why we are talking about CO2 and why we actually need to think about net zero. So that's why in my line of teaching and also in the projects, we are always trying to bring that portion as well into the projects or into the level of understanding that the people are aware why actually CO2 is a big deal or actually it is real, because there are some discussions now or some people don't believe what is actually CO2 and is it really making this kind of a problem in the global context. So if you put them together, like the annual temperature values, because we are all talking about global uh, temperature and also the climate change and everything is related to carbon dioxide. So if you take a look on the temperature anomalies, you can see there is a growth after somewhere around 1900s. The temperature is always growing. And if you correlate it with the CO2 emissions, you can also see it is also going up and there's a relationship. And then this also a question that I get a lot that is it okay? Of course, these things are in terms of shape, they have some kind of a similarity, but it is really the case. And also, we have to talk about the carbon dioxide because we know carbon dioxide is not a toxic gas, it is an essential gas to the normal living context of our world. But the problem is that we are releasing some carbon which is trapped under the earth, which is not in the atmosphere as a gas form. So we are basically releasing, that's where we call man-made CO2 emissions or CO2 equivalents. And then the question is how we measure. How we measure the man-made was the natural uh, carbon dioxide. So basically, it's I'm not that much expert on that, but I learned about these things. So how we can differentiate the natural carbon dioxide, which are in the carbon cycle, and which are coming from the uh, man-made carbon emissions. So basically, when the solar rays are coming into the atmosphere, it will hit nitrogen and then it will create carbon 14, which is a radioactive element. And it has nearly 5,300 years of half-life, which can be measured. But the carbon which is coming from the fossil fuels are millions of years old, more than 100 million years old, including coal. So they are not able to having or they can't have C14, the radioactive version. So therefore, people can look into that and the plants and everything absorb this C14 and it is available, which is possible to have. So in that case, the amount of C13 or C12 in the atmosphere can be measured, and it is also very little. If we go to the numbers, the carbon dioxide is less than 1%, 0.1%, and the global human cost contribution is so much tiny. It's less than 0.0, like 1%, 0.014 actually. And you can see nearly 73 coming from energy and energy related activities. So we have to put big contribution towards that if we are talking about CO2 reductions. So nonetheless, people are always asking why this kind of a tiny fraction can make this kind of a big difference. So that is actually the science part, which is little complicated, of course, for common the people who are not in this field. So it's a potent gas and it is accumulate over time, and it is the question that what it can do over time. And also it can trigger feedback loop. So basically when the temperature or when we accumulate a lot of carbon dioxide in the atmosphere, it will increase the heat. Because of that, the ice caps are melting and then the more water is evaporating, which is again contributing to the heat. And also when the ice caps are melting, the darker spots of the earth crust will appear, which absorb more heat. And again, so that's why it is triggering feedback loops. And because of that, we are getting a lot of problems in our biodiversity and also losing a lot of climate consistency, I would say. And this was a huge discussion. And when I'm teaching some statistics and all these kind of things to some of the students in my university, because part of my work also going like 10%, 15% is actually teaching. So they always ask why this kind of a tiny problem is this kind of a problem and why we really have to worry about it. So the reasons are this: it's a potent gas. It's not the amount, it is the effect. So we have to focus on the effect, not the tiny quantity. And I always take this example to show them. So just to give an idea, because some people think, okay, it is tiny, so we don't have to worry. But they don't care, or they forget actually what is the effect that tiny amount can make. So we all know cyanide, it's a very poisonous material, and by this amount of fraction in the body, people are dying. So it is not the quantity, it is the effect. So carbon dioxide in the atmosphere, it is a very tiny amount, it can be. And during the uh, or after the industrial revolution, people were emitting a lot of carbon dioxide for all the energy related activities mainly. But it grows like 50% more than what we had before. So it is still tiny, and the amount which is absorbed by the natural activities is not enough to fight against this carbon dioxide issue. So likewise, it is not the quantity, it is the effect. And this is also another one. According to the EPA standard, the drinking water can have around 10 parts per billion, which is dangerous in the arsenic. But if you take that in, of course, you will not die instantly, but it will damage your internal organs, and it will go directing for cancers and all kind of these kind of things. So again, it is not the quantity, it is the effect. So we have to focus on that. So then that's how where we come into the net zero. So we have to put a base understanding about, yes, CO2 is a problematic gas. Of course, it is not toxic, but too much also not so good. So we have to understand that level first. And then the concept net zero comes into the
Test.
play. So it is basically not developed by or invented by a single person. So it came into the discussion after several decades of science, understanding, and different research and atmospheric research basically. So the basic understanding is that the global warming stops only when net human caused CO2 emission reach zero. So we have to remove everything what we emit from the atmosphere. So it is basically a simple calculation. If we emit 100 or 1000 tons, we have to remove the exact same amount. So then the net emissions remain zero. But in reality, the question is it possible? And is it really able to achieve? As for example, if you take a look on the petrochemical sector, which is also coming from the fossil fuels or fossil, uh, 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 the petro chemical industry is directly related to the fossil fuels. So that is a very hard industry to shift. For example, the polythene, plastics, and all kind of petrochemical and also the pharmaceutical applications which are linked to that are really hard to shift. So, of course, we cannot stop using fossil fuels because our entire world is now depend on that. But then again, we have a climate issue that the people are struggling to achieve. So, likewise, there were a lot of discussions, arguments about this topic, and then after around 2018, they have mentioned the 1.5 degrees Celsius global warming average temperature and 2-degree scenarios. So where we have to set limits into to achieve the net zero target. So the concept became, so the idea net zero and the policy related things are these are the this concept became the central to the Paris Agreement, which calls for achieving balance between the greenhouse gas emissions and removals in the second half of the century. So we have to actively participate if, so it is a big if we want to achieve these targets. So then people or the policy related things came into the play, and then they put, okay, limiting global warming to 1.5 degrees Celsius, to, and these are not random numbers, also not calculated numbers. So they have modeled what if we reach the global average temperature 1.5 degrees Celsius, what will happen? So there will be a lot of biodiversity loss, water issues, climate issues. And so they modeled what if happens if we reach 1.5, 1.7, 2 degrees average, what will happen. So then they have defined what can we do? What can we do in order to stop this growth and to limit and also eventually to become zero or net zero carbon dioxide. So we emit, but we also remove it from the atmosphere. And if you go to International Energy Agency or any kind of website, so they have listed these kind of things. If we want to achieve net zero by X, Y, Z years, how and what to do. So this is a very uh, confusing area, because from my experience also, if you go to 10 different sites, you will see 10 different numbers. So it is little confusing. So it is easy to understand the problem. Yes, CO2 is making this kind of issues into the atmosphere and to the entire global climate context. And then what can we do? So if we reduce it, it will happen. So there's the people always stuck. Will it help? Will it not help by reducing that? So that's where the awareness is also really important. So nonetheless, so if you go to International Energy Agency and IPCC, for example, they are more or less in line, and you will see different milestones are given, how to do and not how to do, how much we should achieve in terms of uh, achieving net zero. So there are different targets for 2020, 2030, and 2050, and China has its own one, like the dual carbon goal. So they have mentioned renewables, how much it should be, and then when it comes to energy efficiency, how much we should reach, because energy efficiency is not that much easy to achieve. Once you reach to a certain level, the next delta efficiency is of course achievable, but the financial part become little difficult. So we will be talking about that in a short. So likewise, electrification, uh, bioenergy, and then again hydrogen and hydrogen-based fuels, how we can integrate that, what are the targets we need to achieve by 2030 or 2040. Likewise, these things are publicly available. I'm not going to talk about each one of that, but the people are coming technology-based, nature-based solutions to come up with the achievements to put into the play by defining targets. So, and also we need behavioral challenges. So after all these things, we have a budget. So the carbon budget. So this is from 2024, and you can see our budget is imbalance. And also if you go to this website, this is a nice, I would say, a very easy to understand one. So there is a 50% chance if we our remaining CO2 budget is 130. So if you are going with the exhaustion rate of 40 gigatons per year, so somewhere around 2028, we can reach, or we can stay under 1.5. So it is not a guarantee. So this is the likelihood, Steve. So this is also important. So by reducing carbon dioxide, it is also not sure if we reach under that, because last few months I saw some articles, we already in some parts of the world, the average temperature went up 1.5 degrees. So we are already in that situation. So if you go to this website, you can change this dial indicator and you can see. And also we have 1.7 and 2 degrees here. So for example, if you put into the 83% likelihood, we can't reach it. We are already above that. So we have to remove more carbon dioxide than what we are doing right now. So this is the context. So we have a carbon budget, and this is the, I would say, multi-trillion dollar question: can we do this? So the remaining carbon dioxide budget is 130 gigatons, and you can see every year we are releasing like 40, around 35, 40 gigatons, and how many years we have. So what will happen? Of course, we will go above 1.5 degrees Celsius, and then we are having a lot of problems in the biodiversity. We lose a lot of places to, our entire food chain, water chain, sorry, the food cycle, water cycle, and everything get disrupted. So we will be having a lot of problems. So this is the generation, including me and you, and also the younger generation, is the generation that we have to fight against this and to overcome this. So this is where we all are in this discussion today, because we need to discuss and to find solutions actively. So, and also when we come to the greenhouse gases and climate sciences and these kind of discussion, there are hundreds of terms where people are getting confused. So the net zero is actually, as I told, there will be a lot of definitions. So getting to zero greenhouse gas through reductions. That is basically the simplest way we can define this. And there are other things like carbon neutrality, carbon negative, carbon positive, and these are used in different contexts for different purposes. And it is very important to understand what is actually meant by that. So net zero is what we are talking about today, and getting to zero greenhouse gas to reduction. So we need to reduce, of course, removing greenhouse gases as the amount we are emitting. So when it comes to some industries, when it comes to some countries, it is not always 100% possible. There will be always a residual amount. What to do that? That's where the carbon capture, utilization and storage and these kind of things are coming. Offsetting, it's something which I don't recommend, but still these are approaches. And in the same time, we are reducing our carbon stocks like trees. We are removing them. So that is the balance or the imbalance appeared. Nevertheless, net zero is basically that. So that is in short words, because this is a very scientific approach, and when you are going in deep, and also when we are talking a lot about that, it getting bored to some point. So you get bored because it's a lot of informations, and one point of time it is really hard to follow things and get them into the same value chain. So it's important to understand the basic problem, how to, or what is the reason behind it, and then of course what are the possibilities to achieve, or is it really possible to achieve. So to be honest, from my point of view, I personally believe, and I personally know that from my previous education background and the things what I learned from the universities and advanced level and all my academic career, I know CO2 can do this. It is the problem. So I don't have to believe on that because I know it as a fact. So then I am working here with a passion, or like a wishful thinking, that when we deal with the carbon dioxide, and if we do projects, if we do our activities towards reducing carbon, then it can reverse, or it can at least stop what is happening to the world. So that is, I believe. If you ask, are you 100% sure? No, I'm not 100% sure, but I believe it is possible. So we initially, I established the boundary that, okay, their CO2 is making the problem. So if we stop growing the CO2 amount in the atmosphere, or if we remove CO2 from the atmosphere, we can reverse it. So that is my belief. So that's why I'm actively working and also a little bit teaching or spending some amount of time spending to teach younger generation or my colleagues as well. So that is where we are right now. So we as a institute, or from the things we are learning, we are trying to integrate material flow management practices. Of course, that is the tool. So we are promoting circular economy and zero emission strategies to industries. So that is where my main role of this institute is based on. So we are dealing with large corporates, basically large industries all around the world. And that's where we develop practices. So I am specialized, or I am focusing on the energy and green, basically energy part of the industries. As I'm coming from the mineral processing technology from my first degree, I also know the mineral industry also consume not only mineral mining, also mining and mineral industry consuming a lot of energy. And for most of the mines and the mineral processing companies, it is the question that how they can switch. They have the need, they want they have the requirement, and also they are really eager. Some companies, especially in Germany, I know some companies, they are really doing a lot of things to switch their energy to renewables as much as possible, coming from fossil fuels. So as an institute, so I think that we want to talk about the challenges, success stories, what we are doing to achieve net zero. So how we can convince and how we can show someone, are you really possible, or are you really in a position to achieve net zero or not? Or how? If not at the moment, if not, how they can. So that's where we actually working in with the industries. So first, it is really important to know the client, or know the entity that we are working with. So most of the industries, they have high energy demand and they don't have like a proper awareness. It's not there. So what is GHG, and it is really making a mess, and how to calculate the emissions. And then when we initially base that, establish the base, then the problem is data. And do we have data? And then if we ask why you want to do it, or we have competitiveness. So our other parties are, or our other competitors are doing this. So we also have to do, or we have to report it. So likewise, and most of the industries that we have worked with, they are have some ties with European Union. So because of the European Union policies, they have to do it. They don't know anything about greenhouse gas, so they don't care, I would say. And then they are in the need of sustainable transition because someone else wants it. So these are the challenges. And apart from that, high initial investment. So renewable energy, for example, renewable solar, I would say it is cheap, yes, but still it takes some financial commitment to build. So to the initial investment is still high for some countries. So the limited access to financing. So these are the challenges when it comes to, okay, net zero is a must or not optional, but then how to achieve it? Then we have the challenges. So I'm really focused on, because these things we cannot deal with that amount of like scientific basics with the clients, because when you are dealing with the CTOs, CFOs, there's no point of giving them understanding about greenhouse gas emissions, how to calculate that, they don't care. High energy demand, they are already aware, so but that is the challenge coming from them, their side. And then, of course, we need to show why you need to transit. And then we need to show specially how they can tackle this part, initial investment and access to financing. So this is where we are focused. And that is where we are actually good, I would say, in terms of developing financial or bankable projects for these industries. So, and then also we need to take a look why and how we can look into the future, and we have to give them, or we have to provide these industries with a futuristic approach as well. So if you take a look like 10, 15 years ago, the carbon or greenhouse gas emissions were not that much common, and it was like voluntary based. And also people did it out of passion and to test some things like that. And also the question is that the greenhouse gas emissions or these kind of problems were still there. It was already existing, but the commitment from the companies or from the research aspect is not that much. And then in between, most of the people are doing or the carbon reporting, and these things are done because of the recognition of financial gains. Especially I would say not financial gains, mostly the to promote them in the ESG categories. But in the future, as I told, there will be a lot of problems in the biosphere, food cycles, water cycles. Because of that, then there will be a lot of policies, and there will be a lot of rules and regulations come into play. So therefore, there will be people needing to do these kind of calculations and to model where we go. So because of that, the calculation part and modeling part, where we can show the client or to the system or to the industry that this what you are doing right now is sufficient or not. If not, what we can do. And when it comes to what we can do, we need to show them the accurate possibility of doing that, including the financial access. So that is where this link is really important. And because if someone is spending time or money now, they need to know what will happen in the next 10, 15 years and how they can be resilient. So that is also important. So that's these are the concept we are developing. So the market, and of course there will be a lot of financial and socio economical problems in countries, and of course there will be different objectives per country, but as a global challenge, this will be a key requirement in the future, because now there are a lot of wars happen between different countries. So they don't have any concern, or they don't care about these things, about saving environment or saving carbon. It's not any of the concern for them, because they have much more other problems. So this is what we cannot predict in the future. We don't know what will happen, but when we show that with uh, um, so with unity, if we can show this what will happen, this is where you are going, your prices, your cost will be like this. But if you do XYZ in this sector for energy efficiency, renewable energy, waste management, XYZ, and then you will get these benefits. And especially I have to mention here, like if you are talking about water especially, and I'm not specialized in water, but my colleague, they are working in water treatment plants and wastewater treatment uh, technologies. And when it comes to industries, they always put that into the lowest priority, because building a wastewater treatment plant in an industry costs a lot, especially in Germany, and there will be no payback, or the financial KPIs are not existing. But we were able to manage to convince the clients to build the wastewater treatment plants or the water management systems by showing them the cost that they have to consider, that they have to allocate after 5 years, after 10 years, if they don't act right now. Because water will be the next topic, or actually it is the topic for a lot of countries for many decades, but it will not that much prominent because still we are having cheap cost for water, and treatment is not that much of a problem for a lot of, or not a problem, they don't care about it. But when you show, okay, at the moment, if you have to spend 10 million for wastewater treatment plants in several locations, and they say, oh, it's too much expensive, we don't do that. But if you show what will happen after 5, 10 years, because if you are not acting right now, then they have to consider the life cycle cost of that value chain. So this is, then it is important, okay, if we are just showing or just telling, or we are back with some numbers, calculated results with low uncertainty. That is where, or what we are actually doing in this large industry. So basically there are main four strategies. So the resource and energy efficiency part. So understanding and actually going into the industry and looking into the systems. And then what are the applications? What are the tools that we have to use? Is it LCA or what kind of a management strategy? And then of course, global market dynamics. So sustainability reporting, and there are a lot of reporting and different markets also. There are hundreds of standards to follow if you are doing a carbon reporting, which is like the entire system carbon reporting, or product carbon footprinting, corporate carbon footprint, or this is a very big set of standards. And also, most important is the monetary implications and why someone would need to do that. And from my experience, I can tell none of the companies, some companies, they have money in their own accounts where they can leverage to get more money from any kind of a bank, but they never do anything if the project does not have a good or attractive financial case. In a way, it's good because of course businesses has to operate, they need money, otherwise they can't operate. But in the other hand, it is the challenge that, okay, why we should do this. So that is why it is really important to bring the financial aspect strong, and then saving greenhouse gas emissions or reducing it is the cherry on top. So this is how we need to frame. We always need to talk in a language that where the CFOs, CEOs understand. Because being an engineer or being a project manager and talking to a mayor, talking to a CFO is totally a different language. It's really important how we communicate the message to achieve the environmental benefits as well as making some positive cash flows. So when it comes to the technological and operational aspects, mainly the resources and energy part, so how we collect data and what is the main things we have to understand, how much the energy, what is the understanding basically the material flow, including energy flows, and then how we can translate this data. So the data part is important. And as I told, in some countries, they invite us, they pay like 50,000, 60,000 euros to come to them, but they don't have data. So then it is really hard to really do accurate calculations. But then again, we need to show them, okay, this will be your first step. We did the full material flow analysis, but there are a lot of uncertainties on the data part. So you have to put another survey or a full complete analysis to understand where we are stand with the accurate numbers of data model, okay, how reduce that we can reduce. And then the applications and what are the opportunities. So of course, we need to do calculations based on the data what we got, and then what kind of tools, how to model that, and what kind of things we can do or we cannot do, because there are always some challenges coming from the regulatory aspect from different countries. So they have potential, they can't use it. For example, in 2022 in Morocco, I remember the company wants to go for 100% PV coverage of the rooftop, but the excess cannot be sold because they don't have a feed-in tariff for net metering, that kind of approach. So they want to go, but they can't because the regulatory frameworks. So, but still for us, it is not a problem to do the calculation. So we show them because, the large industries, they have a influence towards the political movements and regulatory aspects. So they can use this data to push regulatory aspects as well. So companies, because when this come to net zero and all these kind of thing, not government can work alone. They can't do this alone just by putting regulatory aspects or frameworks. Also, private sector also cannot work alone. So they need the support from the government and also the research and innovation. Out of that, most importantly, it has to be consistent as well. And then the global market dynamic. So am I just doing it, and are we going to link it or doing the calculation towards any kind of any reporting standards, which is a smart way of getting the client on board. Because if we do the calculation, and if we, let's say, for example, if we are doing a carbon accounting, and then if we can do it for as per ISO or greenhouse gas protocol, then it is a win-win situation for both of them and also for us. So they are doing the work as well as in the same time complying to actual standards. So that they can also add some other values for their uh, social recognition, transparency, being environmental friendly, and these things. And then the other one is the financial aspects. So how we can do this, what kind of, based on the data, based on the calculations, based on the applications, how much money we need. Do we have access to the money? If not, how we can find money, how we can leverage our existing capabilities, and so on. So this part is most important. I'm going to talk about this part a little bit, but first I would like to show you out. So this is the fundamental on uh, about any industry based on our experience and how we are playing with them. So approach is very simple. So we do the status quo analysis and then we promote energy efficiency. So in here, I mentioned as efficiency improvement, but also we are talking about waste management and managerial aspects as well. But mostly the first phase is to understand the system, and the second phase is to increase the efficiency, and then we avoid it because if we are looking into renewable energies, there's no point of talking renewable energy at this stage because then we have to generate electricity or whatever the renewable energy for the losses as well. So first we need to avoid by increasing the efficiencies, and then we can look into the uh, renewable energy aspect. So if we take a look the energy related approach, that's where we can move forward. And then this is where the financial part coming into play. And then people say, okay, why should I do this? What is the benefit that I'm getting it? So if I say it's only about carbon dioxide savings, no one will care. So it has to be a bankable project. And then our line of work, but this is what we are doing. So we have a 8-step methodology, but normally in most of the cases, we are stopping at point 6. So we do the analysis, understanding the industry baseline or the status quo analysis, and then how we can utilize the renewable energy sources and regional potentials. And then based on that, we develop the concept because sometimes internally also there are a lot of resources available like waste heat, different synergies between different machines, and using heat from chillers to boilers to preheat water, and there are a lot of things. So in terms of or being material flow analyst, we are looking into the same system in a different angle. So we are trained to do like that. And then we do the data simulations, and then of course we take a look on the financial aspect. So how much money we need to do XYZ project, is it profitable or not? And then the implementation is like we are giving the implementation strategy. We are not doing anything about implementation. That is on the client side. So this is the approach for any project or for any client. And we do a peer comparison as well. So we are showing, okay, if we are doing a project in South America, we do some examples. We show some examples from Germany, like best practices. Okay, these are not benchmarks, but we are showing them what they are doing better than you. Okay, what you can learn from others. Because don't forget, we are coming from Applied Science University. So we are talking about existing solutions. We are not showing them fantasies or the things which are not practical, or I would say the technology readiness level should be in the commercial level. And here I have added what I'm going to talk about here, that modeling simulation, where the where the important part, that to access money, and why it is important to for the client to see the future, and also to show the commitment towards net zero. So that is where I'm going to talk a little bit more and with some examples. So when it comes to a single approach of any system, so this part is going for data collection, engagement, building baselines, and dealing with the client. And then the project identification, what we are doing, calculation, and then we feed that data into the model that we have developed, and then we get scenarios and understanding about what will happen in the future. So basically, the model objective is to see, it has to be user friendly, easy to understandable, greenhouse gas reduction pathway, to understand if they can actually reach net zero or not, and how to leverage it. So this data collection path and these things are just basics, how to do what we have done in order to collect the data and to develop the greenhouse gas trajectory. So then this accurate calculated data, which is in the model, is the part where they can use to leverage to access in order to do these things in the environmental sector of the system. So for example, if I have a system and if I can show the commitment, okay, I'm going to do XYZ projects by the 2030, 2040, or whatever the industry, how they can activate or they can access money and activating their stakeholders engagement actively. So I have some example, I will show you that. So basically the model application is going in this direction. So we talk about the approach, methodology, collection of data, doing calculation, doing peer comparisons, and then we have to define necessary parameters. Okay, where we are right now, what we are going to do in terms of projects, and what are our baseline numbers, or what is our existing or the business as usual context and the scenarios. And then we can structure the reduction roadmap, and then we can deliver it to our stakeholders or to access financials. So basically, we get the understanding. So we have developed our own model, and it is a very, I would say, it will take a lot of time. So I don't have that part here. So once we add all the data about calculation, the emissions related to fuel, electricity like scope 1 and 2, 3 emissions. And then we get the outputs like emission summary. And then also we get this kind of an approach based on the input. So this is where we show the final output. So the model is developed to integrate the scope 1 to 3 activities. Then based on that, we develop the emission balance, and then we add to our model what we are going to do in which year. So then the final output is graphically represent like this, but it is backed with the data collection, engineering calculation, or like the concept for each project, and then the financial KPIs. So to put the project into the model, it has to be a financially attractive project. So this is a small example which we did to a calcite mining thing, because this was also a part of my PhD, so that's why I use this data. So if we do these kind of activities, you can see the overall savings and where they can achieve high and low. So from the model, we can set these parameters. What is the production growth, fuel consumption growth based on the activities. And also we can do what are the transformation values if we have any specific dials. So by doing that, we understand these are possible things. It can be simple things like illumination, we don't know. So depending on the potentials. And then we will show, okay, by 2035, you are going on here. So you have the potentials to do like this right now. And if you do this by 25, 26, 27, there will be the approach. And then we can say, okay, by 2035, there will be a 63% reduction. So then we can say, actually, are you able to reach net zero from your category? And of course, there will be residual emissions and what to do that. That is the second question. But first, we are identifying the potentials, we develop the model, and then we show them what is their capability. And this is a feldspar processing factory. And here you can see there are some minus things and electric dryers. In here, we did the project because they have the potential to do it, because the electric dryers are kerosene dryers are running during the day. So we want to eliminate that and integrate electric dryers. So if they are going for the grid by electric dryers, there will be 16.2 negative minus emissions percentage from the scope 2, because they increase the electricity consumption. But they have a large photovoltaic potential. So when they do it, when they do the PV system, they have the ability to shift that activity during the PV generation time, which means that will be a clear go. So if you can see in here, when they move to the electricity, they are really financially beneficial. They have a very fast payback. But environmentally, it is not. Why? Because grid emission factor is much higher compared to the on-site or the stationary combustion that they are doing for kerosene dryers. Likewise, you can see what they can achieve. It's nearly a 75 reduction by including the photovoltaic portion. Nonetheless, this company actually from Sri Lanka, and they did this one, but the photovoltaic part is still going, because after the COVID, the fuel price went so much high. Because of that, they did the electric dryers in a fast manner, and they eliminated kerosene dryers. I think they kept it as a backup, but they are operating electric dryers because this was economically attractive for them. And then this one is a scenario, because for this one, we were not able to get the data, but we used the publicly available data and we predicted scenarios based on our developed model. So that is the the advantage for us that we can, once the model is developed, we can use it to show clients even with baseline data with some accuracy. Of course, in here there are a lot of uncertainties because we don't know the energy system and how the cross-sector technologies are working. So we did a scenario comparison, what they can do, and cement production, and you can see it is not that much, but if they are going for process development by going to composite cement, they actually can go like 20% reduction from scope 2, which is much more attractive than the previous one. So that is where the calculation based on calculation results are really helpful. And it is important for the client to see their commitments toward the entire period or whatever the defined timeline. And then, so these three examples that I showed you are from mineral mining and processing sector. So how we can use it in the country-wise or like a large-scale version is that we can use it to uh, going for NAMA strategies, nationally appropriate mitigation action plans for different industry sectors, and we can develop like a commitment towards entire sector, how they can collaborate each other and so on. So this is the education and research part. So once you come up with this data, and the next question is, okay, it is possible, good financial KPIs, environmental saving. And then the question comes, how we are going to find money? That is the biggest question. And I took this example from the COP 2025, which is COP 2030, COP 30, which happens in last year. And in here, for the first time, this is the first time I saw, and this is the first time from my all senior colleagues, they also mentioned, this is the first time they mentioned that making financial flows consistent with a pathway towards a low greenhouse gas emission and climate resilient development. Before that, they were all talking about policies, rules, regulation, laws, and all and kind of things. But this is the first time they made it a commitment that the financial flows should be consistent. So it is pressure or like a push towards financial institutions to make sure that their financial flows are consistent with a pathway towards a low greenhouse gas emissions. So we were doing this modeling and data related activities since 2020. So that is 2021 was the year that we initially tested this modeling approach with our clients. And since then, we are providing it to our main client, which is the bank. So why it is important? Because this is a very famous picture that is used by my professors here. And when people are talking about climate change, threaten our existence, threaten our environment, our trees, biospheres, animals will be gone, nobody cares. But whenever we talk about it will threatens our economy, everybody are up and running. So that is the way of communication is important, that we want to talk in that language. So that is where the financing part really becomes easy. So we understood a little bit about the net zero and how to achieve it. So we are promoting the material flow management and circular economy with calculated impact results. So we have to calculate what will happen if you do this project right now or in 10 years. So climate change as a business opportunity, that's what we are promoting. So we have opportunities, so you have to leverage them, and then because of that, you can access money. So as I told, we are mainly dealing with large industries, and basically we are developing concept for large industries so they can develop a full financial plan for the next 10 or until 2040 with their funding partner. So at the moment, we are helping a bank, or they hired us, German Investment Corporation. So we are going for their clients, and we are developing this model, and we are submitting it on behalf of the client. So the bank can see how much money they want in the next 30, 50, or 20 years to reach net zero, or can they reach net zero? So that is basically the link between financial institutions. So it is a big role, and the financial institutions are important. Of course, we need to share the risk. So someone needs to invest, and then someone has to actively participate in doing the activity towards reaching net zero. So again, the question is, it is really important that how that, okay, if someone is going to give you money, how can be we or how can he be sure about the approach? Okay, I said, okay, I'm going to do this and that project, but I want this amount of money. Then the financial institution needs to have an accurate calculated results. Of course, we are doing something based on numbers. So that's where that the modeling part, uncertainty assessment, sensitivity analysis, and these things are all integrated to make a very accurate plan. If you do this and that, you will be able to reach net zero. So I am not going into details about each and individual projects, but every project has its own limits, because some projects we are talking today as green might not be green tomorrow. That's what exactly happened today, because in 50, 40 years ago, the people did things without thinking today. So that's where it is little tricky or challenging to do what we should do now, because people are going with a lot of electric vehicles just to eliminate the fossil fuel in the transportation sector. If you go to China, there's a huge boom. But the question is, how do we build electric cars? Where are the materials coming from? Who controls that? Then it is a different problem. So nonetheless, when it comes to defining the project that we want to do, of course, it has to be backed by accurate numbers, calculated results. But again, it has to be really conservative in the future. It has to be future proof. So it has to be a very clear and conservative approach towards the environmental harm. So that is where the challenge actually now. So calculated impact results is feeding the financial support with the information they need, and then they are investing onto the client. So that is basically a connected or circulating loop, and they also need to know verifying. So monitoring and verification also important. So, and then the green financing part, I think you have heard. So it is something that I really like. And like, even for me, when I initially started working in this sector, we go to clients and we just tell them, okay, you have enough rooftop, just put a PV plant. But we never showed where the money is. Give the money and why someone is going to give you money. So now we have that link. So it is really pushing the industries. And for example, the bank what we are working with right now, they are not going to invest on diesel boilers. They are not going to invest on heavy fuel oil boilers for their clients. So instead of that, they are telling, okay, we will give you 10%, 20% more. If it is like 50 million loan, we will give you 60 million loan, but you have to do this and that. So the company need money. They want to grow. They want money. So the green financing institutes are saying, okay, if you do in this direction, we can give you the money. So it is in a way a success story, and I have a lot of positive uh, projects that happens recently as well, that where the companies agreed to go for renewable energy projects and more like circular economy approaches where the money got approved. And as I told 10 years ago, in the early stages that I joined with the industries, we always show, and the project success rate is like less than 10%. If we promote 100 projects to a client, they will do only like 2%, 3%, maybe not even zero. So, but now there is a high success rate of, because the calculated part is supporting financial institution with the data, and they are telling, okay, we are going to do, or we are going to fund you if you are going to do the project like this manner. So to reduce the greenhouse gas emissions. So then the model output that I showed as a graph will be, or will come to a reality. And then, of course, what is the way forward is like, okay, we talk about reducing it and how to achieving it. So we need to use that. In here, I didn't put AI, but AI also, I think, will be playing a huge role in the future. So, and also the the accumulated data. So we have a lot of data coming from the different parties and different uh, countries, different industries. So we can develop strategies like, for example, that is a dream for me in Sri Lanka to develop a NAMA strategy for mineral processing and mining sector alone by using the outputs of the model and to define targets. Is it really possible? Because some countries, some companies, they just put objectives without any backup or backing up data, no accuracy, just putting a number. But with a lot of data, with doing several case studies in the country, we can develop like this. And also it is important to scope 3 emissions. And as I show you the mineral processing sector, as you know, that all the mineral related products are coming into upstream scope 3 for a lot of industries. If it is graphite, it is a scope 3 aspect for, let's say, battery developers. So if the companies that I showed you, if they can show the model output to their suppliers, we are committed to this plan. This is our greenhouse gas reduction commitment in the next 5 to 10, 15 years. So that means your scope 3 emissions will be going down if you are going with us. So they can go for long commitments, long contracts. So that is also a way. So that is basically from my side today, and I think I talked a lot. And if I'm talking more, I think it will be getting boring as well, because this is a very sensitive topic to talk more and more, and then because otherwise people will lose the focus and they will lose the interest. So I think now also important that we understand that this is a must requirement. So because of that, I think you gathered some insights from me today, and most of the insights are coming here from my experience and my colleagues' experience. So thank you very much. Thank you for your attention. And you can contact me from my contact details for any questions, or now also if we have time, I don't know. Yeah. And thank you very much.
Thank you, Navoda, for your interesting lecture.
Yeah.
And I would like to thank everyone for joining our, this is our 75th Energy Management Forum organized by Sri Lanka Energy Managers Association. And now I would like to open the floor for questions. So if you have any questions, you can either put it in the chat box or you can unmute and raise your questions. Any questions, please?
Good evening, Mr. Navoda and Professor Migara. It was very interesting presentation, and it was your good insight. And as a Sri Lankan, I think it's very important for our industries and our academic institute as well. So thank you very much for arranging this, and I also wish all the best for Mr. Navoda. And Navoda, could you little explain if you want to accommodate this for our I know present BSc curriculum? would you point out something how we can incorporate these strategies at least a little into our BSc degree programs?
You mean the topic net zero or
Yes,
just yeah.
yeah.
That is also that in here also it is a discussion actually because because when it comes to net zero it's a big topic which is linked with several things, and in here also I took to explain it about with the experience and the activities that I'm doing, like the energy part. But in reality, it is not only the energy part. There are a lot of other things from the material side, the production process, and behavioral change. There is a huge network. So I cannot give you a direct answer because that is also a question that we are also looking how to integrate this into the academic part. But what we are doing right now is, I'm not sure if it is successful in other countries, but we are giving it as a subtopic in the material flow analysis part. So we first teach material flow analysis, and then we link it to net zero, how we can use material flow analysis and material flow management to reach net zero, and why net zero it is important. So we are giving some basics like what I just did, basic understanding about net zero, why carbon is a big deal, and why everything can be linked to carbon dioxide, because it can be translated into any topic like wastewater, everything at the end we can translate into carbon dioxide, and also like LCA studies. So then we show net zero is like the final objective, that by doing XYZ, by doing LCA, why we do that to reach net zero. So we are linking that, and it is the way we are doing right now. So it is, I mean, it is important that we need to integrate these things to every sector. So in here, it can be a social science, it can be management, finance, engineering, no matter what. So this concept is embedded. These are now teaching. So it is coming into as separate subjects as well as integrated into existing subject. So that is definitely we have to do, but it's also need to be strategic. That is how I can frame
Okay.
it.
Sure. No. I got some
Yeah.
insight. Thank you very much. Sure.
Yeah.
Okay. Thank you.
So there is a question in the chat box. May I know the
Okay.
product name and the supplier manufacturer of the solar hot water heater integrated with vapor absorption refrigeration system mentioned in the seminar?
It is, this was built, I think, nearly 10-15 years ago. The solar thermal system is connected to the vapor absorption chiller, and the vapor absorption chiller is connected to the HVAC system. So I need to check. I can only remember the developer of the HVAC system, which is Hovertherm. It is a German company based in our area. The vapor absorption chiller, I have to check it. I don't recall it. So during the summer, we are using the solar thermal energy to convert into cooling, and then it is going through the main HVAC system, which is coming to our rooms. And in the winter time, we are using our geothermal system, which is an inbuilt small geothermal system. We are using the temperature difference between summer and winter, the top and the underground temperature difference. I have to check it. I will maybe share with Mr. Chamilo or Mr. Dr. Migara later, so then we can share it. I don't recall the manufacturer. Yeah.
Any other questions? We are already late, so we will give way for two more questions. So I can see Parakrama is raising his hand. So please unmute and ask your question.
Okay, thank you very much. Thank you very much. And Navoda, thank you very much for a most interesting lecture. And also it was very revealing because you talk with knowledge and also background. So that's a very encouraging thing for us to hear. But question I want to ask you, maybe unfair question, whether you are aware of what is happening in Sri Lanka in this regard. Now, we have also signed for the net zero by 2050. But
Yeah.
at the present moment is just a statement. Nobody
Yeah,
seems to
yeah.
pay any attention. Also, now we have also declared our NDAs,
Yeah.
that will be. But again, nobody pays any
Just,
attention. But
yeah.
but what you mentioned is the most important thing is for people to take attention is that a cartoon you showed. Climate change is going to affect our economy.
Yes,
That
exactly.
is the driving force that we can hopefully make people take notice. So a lot of things are available on the ground and systems, but that's what I want to ask. I mean, maybe unfair question, but any views on this?
No,
How
no,
we
of course
can
it's yeah, it's the sad truth, and to be honest, it is not only Sri Lanka but some countries as well. They just put numbers and they just put just sentences.
Mm.
No one knows how to track. No one knows how to calculate, and even this. And I 1 week ago I was in China and I met a person with big bank over there, and he doesn't know, he's the climate expert of the bank, and he doesn't know how to calculate a simple emission coming using an emission factor. So it's everywhere it is the same, and the Sri Lankan context is really, yes, that's true. But again, that the policy alone cannot work. That is my understanding. Of course, the financial force has to be there, and of course, the private companies has to put something. And my colleagues here they are Germans actually, and they used to work with Sri Lanka since 2008 2010, somewhere around that. And they have links to a lot of ministries, some companies, and they were not doing anything at all. So it is actually not an unfair question, and actually I'm also in a confused position that how we can motivate the people. And the cartoon that I showed is it's actually real, because in here that is our only strategy we are using. We are showing the financial benefits and also what will happen if you not act right now, especially in the water sector. We are showing if you don't act right now, in 10 years 5 years you will be paying three times more than what you have to do right now. So basically, in Sri Lanka, the NDAs, and I take a look, I can't recall, I maybe the updated version, but it is not that much, I would say, directing in a proper manner. Just wording.
Well, I don't blame you, but that
Yeah.
is the problem we are having actually.
Yeah,
So,
that's true.
like you said, it's the private sector who should recognize the economic
Yeah.
value of this. And really, like you mentioned sometime earlier, somebody going away from kerosene. Right now, because of the recent jump in price of fossil fuel, it's
Exactly.
really driving force.
Yeah.
Yeah. Okay.
Yeah.
Thank you, Navoda. It's a very revealing
Thank you.
lecture. Thank you very much.
Thank you.
Thank you very much for that question, Mr. Jayasinghe. So, any other questions? May this be the last question, since it has been a very long energy management forum. So usually it is 1 hour, but it has taken 1 hour and 40 minutes.
Yes,
So now someone is asking, could you share the presentation material? I think that
I already shared material with Mr. Chamila and Mrs. Nimashi.
so
That
I think
one,
the SLEMA office will share it with the participants.
Because the one I did, I had some numbers which I cannot share. I can only show because these are some of the numbers coming from some companies. But I shared edited version, which is without the numbers. So it is already with SLEMA, so you can share it. Yeah.
Floor is open for the last question. So it seems like it has been a very long seminar today. Anyway, finally, I would like to wind up this. This is the 75th Energy Management Forum, which is organized by the Sri Lanka Energy Managers Association. So on behalf of the SLEMA and the Ensure team, I would like to thank Mr. Navoda Senanayake for his very inspirational lecture. I think that you covered very interesting facts, and those most of these are very new to us, and thank you very much. I think that these are things that we should really engage in near future in achieving net zero. Finally, I would like to thank all the members for attending today, and thank you very much, and see you at the next Energy Management Forum. Thank you very much, everybody.
Thank you. Thank you.
And thank you, Navoda.
Yeah, thank you, Dr. Migara. Thanks.